Hello, everybody. Thank you for joining us today. You are part of the almost 450 people worldwide who are registered to this webcast. This webcast is powered by Yole Développement, KnowMade, System Plus, and it is dedicated to wireless technologies for 5Gs. My name is David Jordan, and I am Global Sales Support and Coordinator for Yole Développement. So before we get started with this webcast, I would like to share with you a few information regarding logistics. So you have the possibilities during all webcasts to submit questions. So in order to do so, you simply have to use the box at the bottom of the screen with the label Ask a Questions. We will answer as many questions today as time permits, and for the remaining questions, we'll make a follow-up with you by email. Concerning the material and all the contents from this webcast, please note that the presentation is already available in the resources section. You will also receive an email after the webcast with a link to the recording session. So today, Yole Développement, KnowMade, System Plus Consulting will share their analysis for you on wireless technologies for 5Gs. First, let's start with a short introduction presenting 5G drivers and use case presented by Cédric Malaquin. He is a technology and market analyst at Yole Développement, and he specializes in RF devices and technologies. Cédric, it's your turn.
Okay, thank you, David. So hello, everyone. Thank you for joining our webcast. So today, Yole Développement, System Plus Consulting and KnowMade joined their force to build this webcast, and we extracted the slide you will show on this report from present report available and future report that will be built in the coming weeks. So the first one just is the 5G impact of the RF front-end module and connectivity for cell phone. First of all, we all know the global mobile data traffic forecast is increasing so much. With the coming 5G, we all are questioning about the impact for RF front-end industry and what about the connectivity technology for cell phone market. Okay, just to mention from the VNI Cisco report, mobile data traffic is expected to grow by 2021. 20% of the global IP traffic will be mobile, mostly 4G connection, but also 5G connection will start by 2021. It will be 1.5%. And another point which is important to note is that 63% of the global mobile data traffic will be offloaded to Wi-Fi or small cells. Among the mobile data traffic, the main application hungry for data is, of course, the video, which is and will remain the main driver of the data rate increase. So this is the first motivation for upgrading the network is the global data traffic forecast. Ericsson predicts 75% of use case will be video by 2023, confirming TV market replacement by the mobile will continue. Among all the 5G application, you have other application than the mobile. For instance, the IoT application for connected homes, agriculture, industrial automation, and so on. The arrival of VR and AR applications as well. Robotic services, intelligent transport system, for instance, autonomous vehicles. Sorry for this slide, the crew is not well oriented. It is an issue with the platform, but this will be corrected on the report online. So you can show on this plots, all these applications require different amount of data demand and reliability level, meaning the use of different frequency bands and different technologies. So for the sub-6, that will be support most of the enhanced mobile broadband as usual, with more and more carrier aggregation and those kind of things, which make some pressure on the RF front-end design and structure. But also, millimeter wave will also be necessary for extra capacity needed to support very demanding application, such as, for instance, the VR, AR, this kind of things.
Okay, thank you very much, Cedric, for this introduction. Once again, do not hesitate to ask questions in the chat box. We'll continue with a patent landscape analysis from Paul Leclerc, patent and technology analyst at KnowMade. Paul, it's your turn.
Okay, hello everyone. So the next part is dedicated to the technologies that will make the 5G revolution possible. And the way we're going to dig into this technology is not through maybe more classical market analysis or reverse engineering technologies that you may be more familiar with, but by analyzing the IP position and the patent landscape related to those technologies. So the next part will be focusing on two technologies, so the RF front-end module and the acoustic wave filter. And these results and data that I'm going to present you are extracted from two different patent analyses that we've done at the end of 2017. So if you look at the time evolution of the patent publication related to RF acoustic waves, you can see that after huge growth in the beginning of the 17th and up to 2005, which is due to the development of smartphone technologies, there is a decreasing of the patenting activity of about minus 6.5% per year. And so the question is in spite of the numerous frequency bands that are going to happen in the 5G application, so for Cedric mentioned the sub-6 gigahertz, but also the 24-28 gigahertz that requires many filtering operation, we cannot see a huge increase of the patenting activity, and that's something very strange. And the question is why there is no sign of such evolution, of such increase of the attraction of filtering steps. And this decrease also happened for both SAW technology, so surface acoustic wave technology, but also BAW technology. And it's really strange regarding the huge attraction of 5G for all the cell phone application. So if we look a little bit more into details on this IP landscape related to acoustic wave filter, what we can see is that if we look at SAW filter, so the most developed IP landscape with the highest number of patents, and if we look at the main IP player activity, you can see on the graph the number of pending patents, so that is related to the most recent activity of this player. Against the y-axis, you have the number of granted patents, so the real asserted technology. You can see here that Murata is leading by far the IP landscape with a very high number of pending ungranted patents and will be an uncontested IP leader for the next 5 years. And then you have the small competition, which is starting to emerge, but not that important, between Skywork and TDK. And I just remember that TDK has a joint venture now with Qualcomm. So it's a small competition, but this competition will not really affect the IP landscape. And so this IP landscape is very settled, and there will be no major change in the next 5 years. So we don't expect any very big event happening at the SAW filter level. However, if you look now on the BAW filter technology, which address higher frequency in terms of filtering operation, you can see that the landscape is very different, and the evolution will be very different, with many changing in the next year. Indeed, you have here two main IP leaders, Broadcom and Yole, that have led the IP landscape for a couple of years. But as you can see, their patenting activity is a little bit is decreasing, and so their position is a little bit struggling. What is very interesting here also, by looking at this IP landscape, is the presence of newcomers like Acoustics, Resonant, or GSET that have entered the IP landscape in the last 8 years. And that's very interesting, because SAW filter IP landscape doesn't have this kind of newcomers. And here in the BAW filter, you have newcomers. That means there is people that try to enter this landscape and to assert their technology, in spite of the fact that there is very big and strong IP players that are set up for a couple of years. So it's very interesting to see newcomers, because it shows a very dynamic IP landscape. And then the last thing that we can see here from this graph is that there is a very strong competition between Qualcomm, Skyworks, and Qorvo that really have pushed and developed a high patenting activity related to BAW filter in the last year. And if you look at our prospection, you can see that these three companies will be very close from each other in 5 years. And so there is a strong competition that is happening at the IP landscape regarding BAW filter. And this competition is also a witness of the attraction of BAW filter to address sub-6 GHz application. And so you have a very strong competition, and that means these players are really trying to race to this technology. And even something that is more interesting today is when you step back and take a look at a higher level, so at the module level, and the RF front-end module, what you can see here is that all the main IP players that I presented in the previous slide are exhibiting an increasing patenting activity related to the front-end module. Everyone but Broadcom, which show almost non-activity since 2012. But other than Broadcom, all the other players have shown a very interesting and an increase of their patenting activity related to the front-end module. And also what is very interesting, if you look at their recent patent publication, you can see that whether this is Murata, Qualcomm, or Skyworks, or even Qorvo, there is a real trend that goes from the device to the module onto the question of how integrate the RF, the device, and here the acoustic wave filter into a RF front-end module. And this is a trend that shows that today IP players are looking into at a higher level in order to assert their technology and invention, and instead of now just focusing on the component, they focus on the component, on how to make a function from this component and how to integrate it into the module. And so there is a development of the IP activity related to the RF module architecture, and that's something that we think that's going to drive the IP landscape in the following years, which is really the focus on how to integrate all these components into a module. And that's a really interesting point to follow regarding this IP landscape. And so to conclude about the IP landscape regarding the trend that we see on acoustic wave filter and RF front-end module, what we can see is that the SAW-related IP landscape is very well settled, with Murata that is uncontested leader, and there will be no change regarding the SAW filter in the next 5 years. However, you have a strong competition that is starting between Qorvo, Skyworks, and Qualcomm regarding the bulk acoustic wave related patent landscape. And this race is shown by the number of filing patent related to this application, and these patents are filing worldwide, which show that really their will of asserting their technology and asserting their market position. And also something that is very recent but very interesting in terms of trend on IP dynamic is the increase of the RF front-end module related IP activity since 2010. And this increase of the IP activity is mainly due to the entrance of newcomers, so Chinese players, for example, like Oppo Mobile, but also the increased activity of the IP leader like Qualcomm, Murata, and Skyworks, which shows the really attractiveness of the IP domain. And so really, if you have to remember one thing about this IP landscape analysis, is that the IP landscape is now led by the market leaders, which show that the IP landscape are very settled, and these IP players are engaged in a fair competition, and this competition happened at the BAW filter on RF module component in order to assert their position regarding 5G application. Thank you for your attention.
Thank you very much, Paul, for this patent investigation overview. Let's go now to the next presentation made by Stéphane Elisabeth. He is project manager at System Plus Consulting, and he will provide a technology overview of all the RF front-end modules. Stéphane, it's your turn.
Thank you, David. Hi, everyone. I'm Stéphane Elisabeth, cost engineer at System Plus Consulting, and I'm in charge of RF, image sensor, and advanced packaging, reverse costing. And I represent some recent observation made by System Plus on RF front-end modules to see where we are going to 5G. So to begin with, I will present the past architecture. The implementation of 3G communication has bring a quite simple architecture. Now today, with the 4G communication implementation, we have integrated a more complex and more wide architecture as described. The main path with PIM ID and a diversity path driven by diversity switch. This is true for high-end smartphone, of course. But in the future, how the 5G will be implemented inside our smartphone, which technology will prevail? I'll try to give you some clue in this presentation. So to get an overview of the main supplier market share, we analyzed over 10 smartphone and smartwatch front-end modules, which has over 14 components. And it's revealed that Skyworks seems to get the higher design win in the smartphone industry panels, from the high end to the low end, followed by Broadcom, Murata, Qorvo, and TDK EPCOs. All the front-end modules analyzed show two kinds of integrated filter technology for the sub-gigahertz communication. And the two technology has its own frequency domain. And as shown here, SAW filter as for the low band application and BAW filter for the high band. But with new player coming, like Resonant, for example, there is a hard competition on the mid band based on criteria like design, cost, performance, where the two technology can compete. And these two technology are based on different approach. On one hand, SAW filters are based on acoustic wave propagation at the surface of piezoelectric. And as the technology uses surface wave, it's kind of limited by the interdigital transducer distance. But on the other hand, the BAW filters use acoustic wave propagation inside inside the piezoelectric. And depending on the wave velocity inside the piezoelectric, the frequency propagation is linked to the piezoelectric thickness. So by doing so, in theory, the technology has no limitation. And we can see that we can split the supplier with these two technologies, Skyworks, Murata, and TDK IPCOS for the SAW manufacturing, and Corvo, Broadcom, and Taiyuuden for the bow manufacturing. And this last one is integrated in the split, even if it doesn't have any front-end module. In fact, Taiyuuden is a third one supplier for a front-end module manufacturer, Skyworks. And with TDK IPCOS, also supplying the company with some SAW filter in the low band frequency, Skyworks is the only one manufacturer with front-end module production on all the frequency domain. TDK IPCOS is also supplying Corvo in the low band application, allowing the company to be on two frequency domain, low and high band, and with two technology applications, SAW and bow filter. Finally, with in-house capability, we have the three companies completed the landscape. So in our 2018 RF front-end modules report update, we analyzed over 10 smartphones, from the high-end smartphone with large RF front-end module area, 6 to 400 millimeter square, with highly integrated system-in-package devices, to a low-end smartphone with around 300 millimeter square and several discrete filters. And as a first result of our analysis, here is some direction taken by the several analyzed OEMs. As expected, the diagram shows that high-end OEMs have the potential to afford fully integrated solution, with a major part of the RF area allowed to PIM ID. The smartwatch is a separated case with a full PIM ID solution that could come from Apple's requirements. For the smartphone part, we can see that diversity modules has the second place in the technology share, and it's increasing compared to 2017 reports. And as the diversity modules increase, the SAW filter share also increase in the smartphone. We can see that in high-end smartphone, integrated filter are 2 times higher than low-end, reaching almost 15 filter integrated inside modules for Apple, for example. And the more OEMs seek for more integrated LTE band compatibility and reduce PCB footprint, the more filters are added inside the modules. And today, the main trend in high smartphone is to integrate more and more. In the iPhone 10 application, Apple has 2 versions with 2 different approaches with the same supplier, Broadcom. On one hand, we have 2 separated modules, and another with mid and high band front end in one integrated in one modules. The huge drawback of the integration of all-in-one is the increase of the footprint, over 22% of increase, but with 3 non-negligible advantages. By keeping the same amount of filter, they could integrate IPD inside the modules, and they reduce also the number of in-out pins. Doing so, they reduce the communication, the link between modules, and they increase the performance of the front-end modules. And finally, to manage the electromagnetic interferences, Broadcom chose to integrate several shielding solutions. The SiP is fully externally metallized and grounded, with internal ground wire bonding to shield the critical dies, for example, the IPD. And also, Skyworks has also some improvement in terms of packaging. As the diversity switch are adopted, they try to integrate more and more to provide small form factor solution. And like Broadcom, they integrate internal and external shielding by using wire bonding and metal sealed packaging. But another improvement from Skyward is the integration of the IPD outside the SIP in a kind of face-to-face configuration that is completely isolated from the filters. And finally, what can we expect it from now toward the 5G application implementation? The main challenges will remain the packaging. As we know, Qualcomm is working hard toward the technology implementation and will be a hard competitor in this field. And knowing that 5G will work in millimeter wave frequency domains, we can see what are now available and what could be applicated to 5G SIP. And here there is the WiGig devices working at 16 gigahertz from Qualcomm, and it is a highly integrated double-side molding SIP that is integrated in two working devices, one in industrial application integrated in a router, and one already integrated in a consumer application in the mobile devices. And of course, System Plus will follow the technologies and will write the history through its reports. Thank you for your attention.
Thank you very much, Stéphane, for this interesting and in-depth technical view inside a different flagship smartphone. Now we will finish with the presentation of Cédric. Cédric will add some valuable information on this topic before we end the webcast. Cédric, it's your turn.
Okay, thank you, David, and thank you also, Stéphane, for providing all this interesting information. So, as everybody knows from the well-known Shannon equation, network technologies upgrade is supported by several key technologies. So first is the network densification, which will provide average data rate improvement from every user through the implementation of small cells, for instance. And also another point is every slice of radio band have to be optimized to get the most of it. So to manage this improvements in terms of spectral efficiency, two schemes are being employed. So the first one is the high order of modulation. So the QAM today, 256 QAM is the most common modulation scheme. It will remain, I guess, for a while. And the second one is the MIMO technology, which is employed 2 by 2 to transmit 2 receive paths, but now 4 by 4 is well employed as well by most of the players. Finally, the last one is about the bandwidth available. So to achieve more bandwidth, two solutions exist. So one is to get more spectrum allocation, especially through the new radio band sub-6 GHz and also the millimeter wave, which is coming right now. But also the path that is well followed is the carrier aggregation, which is the current mainstream technologies to improve the bandwidth and the capacity network. Okay, about the carrier aggregation, the MIMO technologies, you can see here a picture of the modem capability on those two technologies. So it depicts the data rates capable that the modem can handle as a function of the component carrier and also as a function of the MIMO technology. So yesterday people build 2-3 component carrier using 2 by 2 or 4 by 4 MIMO, on one carrier. And on the current flagship phones, we can find products that capable of stacking 5 component carrier, and MIMO 4x4 on 3 component carrier, and 3 of the main modem supplier, Qualcomm, HiSilicon, and Intel, provide device capable of handling those kind of things. For the next generation of phones, it is expected that this trend will follow, with 7 component carrier expected, and MIMO 4x4 on 5 component carrier. So this is for the carrier aggregation, and the MIMO as well, 4x4. The QAM, as expected earlier, certainly will remain 256 QAM since the third modem generation, and additional path could be the millimeter wave technologies that come as a disruptive technology to traditional carrier aggregation scaling, and it is currently developed by modem vendors, but also carriers looking very far away at it, and this could be a view in the next future generation of handset as well. Okay, another point, the LTE network is evolving, but also the technology, the Wi-Fi technology is evaluating as well, and is accelerating. It now can manage multiple user cases and theoretical reach above a gigabit per second of downlink speed. Analogy with the front end is noticeable with the use of the sub-6 for the Wi-Fi 11A and 11AX, but also on the millimeter wave side with the 60 GHz WiGig technology. Those two technologies complementing each other. Okay, here is an overview of the market forecast for the RF front-end component market. So 10 years forecast. You can see on this overview the onset market is consolidating of the 4G device up to 2019, and the introduction of the 5G device will appear 2019 as well, with the sub-6 GHz technologies. And also the first 5G millimeter wave device will appear in 2019. Okay, the overall front-end market value is expected to reach 30 million by 2023. Finally, this is a view of the RF front-end ecosystem complexity, which is depicted. All the players among the supply chain are moving very fast to consolidate and strengthen their position. Handset makers adopt more and more integrated modules, as Stefan explained earlier, and are closer to IC design chip maker than ever. Modem and transceiver providers are positioning the millimeter wave technologies to try to enter the front-end module as well, and to disrupt this ecosystem, supplying high data rate solution with different technologies. The traditional front-end module supplier work closely with OSAT, and new entrants such as Qualcomm are building new fabs also to prepare the sub-6 market entry. Another point on the RF component stage, the competition is intensifying and cooperation is opening as well at the meantime. For instance, the filtering market, as depicted by Stefan and Paul earlier, is really quite complex, with SAW and low technology competing and trying to get the most of the market share. And the last point, I wanted to mention a parallel supply chain could also emerge with highly qualified companies such as Resonance, providing IP and filters to PA companies, allowing it to build a PA-MID offer at a competitive cost. Okay, thank you for your attention. Any question, please ask, and we will be pleased to support.
Thank you very much, Cedric. Thank you all for your relevant presentation. We are now going to wrap up with a Q&A session. We will answer as many questions as time permits, and we'll follow up via email for the remaining ones. The first question is for you, Cedric. What frequency band is most likely to happen in the millimeter wave regime?
Okay, thank you for the question, David. From my understanding, millimeter wave is a differentiating technology for service provider. We saw really in the recent events that carriers such as AT&T or Verizon in the US acquired license in 28 and 39 gigahertz band through company acquisition for fixed wireless access. But also people like T-Mobile, carrier like T-Mobile on some spectrum in the 28 gigahertz band. You also have from Korea a 28 gigahertz auction that will open June this year, and also on the Japanese market, NTT Docomo completed trials mainly on the 28 gigahertz frequency. So to answer the question, I think the main focus today is on the 28 gigahertz right now, while for US and Korea and Japan, while for the Europe and China, up to now the focus mostly remain on the sub-6, but 26 gigahertz bands most likely to be used in Europe within 2 years. But just the main frequency band that should be used today will be the 28 gigahertz for sure. Okay.
Thank you. Next question. Thank you very much. The next question for Paul. Broadcom IP activity seems to be low compared to the other player in what you presented. Can you comment about Broadcom current IP strategy and position?
Tricky question here. Yeah, in fact, Broadcom IP position is quite interesting because Broadcom have a very broad, wide IP portfolio. His technology is very well known, and he has strong patent with on key patents regarding this technology. However, its IP activity has really decreased over the last 8 years, and today really we don't see any activity from Broadcom. Also regarding different reverse engineering we perform, we don't see any change in their technology and in their product. So really, Broadcom is a question mark. Either they have changed or switched their strategy to another domain, which may be possible, or they are doing something underground. But Broadcom's IP activity is in a standby mode for now, and really we don't have any clue or any information or trend that can show an evolution or an increase of their patenting activity in the coming years regarding either the acoustic wave filter or the front-end modular. architecture. So really, it's a big question mark, and we don't have any very specific answer up to now. We have to wait until they file new patent invention.
Thank you very much, Paul. Next question is for Stéphane. How do you envisage the RF front-end evolutions in the next few years?
Okay. So about the front-end module, as we managed to make two different reports, so the 2017 and the 2018 version of the RF front-end module inside the smartphone, we can see what kind of trend the OEMs are taking. For example, for the high-end manufacturer, we can see that they use more and more PIMID, and it's spreading toward I think mid-hand manufacturer, but for the low-hand manufacturer, it's definitely a solution too costly to work with. But we have seen that, for example, Xiaomi try to integrate more integrated modules, but without any duplexer inside. They came from a completely separated solution last year to PIMID, just PIM from Avago, for example, and antenna switch from RFMD. So I think we will move toward integrated solution, but we will still have a separated domain between high-end and low-end manufacturer.
Thank you, Stéphane. Next question for Cédric. Do you see 8x8 MIMO coming in the handset?
Oh, okay, thank you, David, for the question. 8x8 MIMO is a technology, as explained, that should enhance the data rate, but this will certainly enter the premise equipment market, but certainly not in the mobile. There is several reasons for this. First is I think we cannot take advantage of it 100% of the time, even in dense urban area. So the radio cost benefit should not be good enough to pay for this technology in the mobile phone. Okay, it's not easy to find 8 available stream to work with it. Plus, I think there is a lack of space for it in the handset, which is already filled with 8 to 10 antennas. The trend is more now on the antenna sharing with Wi-Fi and LTE share antenna, those kind of things. Not add another amount of antenna. I think it only makes sense for the millimeter wave part with the beamforming management, but this will not be the same kind of antenna for the millimeter wave. You will have dedicated antenna, patch antenna, linked to the transceiver that will deal the millimeter wave. And this would be a different circuitry from the front end that is typically currently used in the front end. One other thing is the dual connectivity brought by the 5G with, let's say, fat band, new radio bands that would be anchored on the LTE one. certainly will bring the same benefit at a lower cost compared to adding different paths to the front end. This is my opinion. So.
Okay, thank you very much, Cedric. Well, last question. Do you see any future litigation to come in the acoustic wave filter or in the RF front-end module domain?
Okay. We never really know if there will be a litigation that happen, but looking at the different player or main player aggressiveness and the different litigations that happened in the past, what we see in these two landscapes is that on the SAW filter, most of there were not many cases. Even Murata, which has a very high number of granted patents, hasn't been very aggressive, and there hasn't been many litigation, at least in our knowledge on that went public. Regarding the BAW filters, I think Broadcom is a little bit more aggressive, and because, as I said, there is a strong competition that is coming, there will be more chance. But now there is so many different architectures and so many different technologies that it could be difficult. However, what could be very dangerous, and some player that has started to also enter the IP landscape are patent trolls. For example, Intellectual Ventures has bought several patent families from Avago Technologies, I think 6 years ago. And the competition, the attraction of the 5G may lead to some action from this patent troll in the future. So I don't see a main IP player involved in patent litigation, very in the coming year, but there is still some very important important risk from the patent troll, and for example, Intellectual Venture is one of them.
Okay, thanks. We have a question for Stéphane. Will the first 5G phone have a separate path, or will they have integration with 4G LTE? And in case of separate path, do you see discrete or module component?
Okay.
Thank you.
Okay, that's quite a nice question from Infineon. In my opinion, I think for the first integration, it could be a separated path. As we know, all the manufacturer is working on system in package to integrate passive or inside the substrate, or also glass substrate to be used in 5G. I think it will be in modules and separated in the first part. After, maybe it could be integrated as the EME shielding will advance. But yeah, I think for my opinion, it will be modules and separated paths.
Okay, thanks. So let's take a last question for all our speakers. We have over 40 questions, so we will answer the remaining questions by email. So last question for Cedric. How do you see the new radio band implementation in the handset?
Okay, it's a tough question. Right now, this is 5G non-standalone implementation that is happening. That means sub-6 new radio bands are anchored on the LTE-1. This is a dual connectivity. this way of doing will enable leveraging LTE spectrum acquired by the carriers. And I think this is the way new radio bands will be implemented in the near future. This will again increase the complexity of the front end, which is already quite complex right now because of the new path to be managed. But I think today with the carrier aggregation rising, this case aggregating the new radio bands on top of the LTE-1 will be the way that people will pursue. For the new radio millimeter wave implementation, this will be a different thing. So Stefan told a little bit just a question before, but I think this new radio millimeter wave bands will require a separate path front-end transceiver, specific antenna, and also specific challenges to be solved, such as, for instance, the radio links that have to be maintained between the base station and the device for non-line of sight case or long-range communication, those kind of things. And also, one other important point to look at is the power consumption of the device because of the power available on set, which is not so huge. So again, this millimeter wave technology implementation will look quite different from what we know from the front-end industry. Okay.
Thank you very much. Last question for Paul. You mentioned the increasing activity of Chinese players. Can you give us more information about who they are and their technology?
Yeah, I'll try. Indeed, among the newcomers that have entered the IP landscape over the last 8 years, there is many Chinese players. I think it's maybe due to the activity of Huawei and ZTE that have really brought many Chinese players into this kind of technology. It's difficult to answer. There is, for example, most of the newcomers are in the RF front-end module IP landscape. I think because it's something that is new and there is more white spaces. For example, Oppo has started to file patents related to a front-end module. You have also Liwitech that have started to file some patents related to the front-end integration in their transceiver. RDA, microelectronics are also entering this landscape. So there is also a lot of university, and most of them are really entering the front-end module IP landscape. Regarding the acoustic wave filter, I think most of them really enter by looking at bow technology. I mentioned GSET that has patenting, I think, about 20 inventions regarding the packaging of the bulk acoustic wave filters. There is also a company from Jiangsu Electronic Technology, microchip technology also that has entered this landscape. But it is really difficult because, as Cedric mentioned in his last slide, the environment is very dense. It's moving a lot between front end to components, and there is a lot of links. And the Chinese are also filing a lot of patents, but the one I mentioned, so Oppo, Liwitech, RDA, and microchip technology are among the players that have filed numerous patents in the last year. And I'm sure there will be more to come, and it will become more and more dense and complex environment.
Thank you very much, Paul. So that was the last question. The webcast is now ended. So just to remind you, you will get an email in the next 24 hours where you will have a link to the recorded session of this webcast. So feel free also to share the presentation or the video with your colleagues. You can find on our imicronews.com website more information on our reports and the latest news of the industry. If you still have a few questions, you can still send them to our colleagues. You have all the contact details on the slide that is currently appearing in the webcast. So thanks a lot. Thanks for joining us. Thanks for all the presenter. Feel free to contact us by email if you need, and have all a good day. Thank you very much.